Awesome. So today's talk is about navigating multi-cloud and a hybrid cloud architecture together with Google Cloud. I will caveat this in saying this isn't a explanation of this is how you set it up and this is how you do X, Y, Z. The point of this talk is more for you to understand if if you're considering multi-cloud or hybrid cloud implementation of your solution, what are the things that you should be taking into considerations? What are the use cases? And there will be a short demo of what it looks like running an application on Anthos on both GCP and AWS. So the agenda, pretty quick intros. We'll get into the talk. We'll do a demo and a bit of summary and Q&A. My name is Joel Goodman. I'm a staff cloud architect for DoiT International. I've been with DoiT going on 8 months now. I lead a team of customer reliability engineers and solution architects out of Israel. And before coming to DoiT, I worked for Google as a customer engineer, solution architect for 3 years, helping enterprise customers in their application modernization and infrastructure modernization journeys. So setting up Kubernetes environments on-prem, in the cloud, and everything in between. So let's start with some definitions, right? Before we get in, so we're talking the same language. I've been in multiple conversations where people confuse private cloud with on-prem, with all kinds of different things, and it's just a very hard conversation if we aren't talking on the same definitions. So first off, we've got the public cloud, and essentially the public cloud is any one of the hyperscaler clouds, Google, Amazon, Microsoft, but other third-party clouds as well, which essentially provide you their infrastructure and services, usually in a pay-as-you-go model, where you can consume on demand various services, whether it be compute, storage, networking, machine learning services, and anything else. Then you have the private cloud. Private cloud is what we refer to as cloud environment that's usually run on-prem, either by the customers themselves in their own data centers, or where they have servers hosted in a co-location in someone else's data center, but you have your servers co-located there. Now, if we are talking about a multi-cloud environment, right? This could be any two clouds, right? It could be Google and AWS. It could be Google and on-prem. Google and private cloud. It could be any combination of those where you have workloads running that are individual, right? You have one application running in Google and one application running on-prem because it has to be on-prem for certain regulatory requirements, right? That's a multi-cloud environment. We have two things. They're not necessarily connected. Yes, there could be communication between them, but there isn't a hard connection between the two, and you're just running separately in two environments. Then you have a hybrid cloud scenario. And a hybrid cloud scenario is any scenario where you connect two clouds together. So it could be on-prem and Google Cloud, or Google Cloud and Amazon, right? So some of the scenarios for this could be, for example, if you're in the process of migration. So from your private cloud environment, you'll set up a VPN, you'll set up an interconnect, something that tethers the two environments together. You start migrating data. You have a duplicate environment running in both scenarios, and you're running in a hybrid cloud environment. Another possibility is, for example, if you want to run a workload on AWS because they have certain tools that you love, you know, and you want to use them. But for example, you want to use Google for your data backend, right? Yeah, fully managed data pipelines running on Google Cloud. So you would set up a hybrid cloud selection. You would have your front end, your app running there, and then the data being sent to Google on the back end. Now, another two definitions which I want to touch on are monolithic architecture and microservices architecture. So essentially, whenever we're speaking with customers about infrastructure modernization and application modernization, the scenario usually is they have some sort of monolithic app, which is usually like a 3-tier application with a front end, a business layer, and a data interface. That's pretty monolithic, that they want to move to Kubernetes, they want to move to a microservices architecture, they want to run it anywhere, they want that flexibility. So a monolithic app, as I said, 3 layers with a single database, very, very heavy, everything's in one place, very, very fragile. So any change inserted into the environment is relatively dangerous. And that's one of the reasons why customers want to move to microservices architecture. In a microservice architecture, essentially, you're separating the different environments. Everything is run as a service. You have dispersed environments, and it's a much more reliable environment. With that being said, the trade-off here is the complexity of managing your infrastructure goes up, but you can make changes to your application and your environment quicker and more reliably. Okay, so some of the use cases, right? And obviously there's multiple, but these are the main scenarios. These are the main scenarios that we have seen where people have implemented, where customers have implemented either a hybrid or a multi-cloud environment. So the one is lift and shift, right? So you're running on-prem, you have your VMs on-prem and your data center and everything. You set up the VM, you set up a VPN or interconnect connection, and you just replicate that exact same environment into the cloud. Now, yes, that would have the benefit of some cost savings once we turn down the on-prem environment, the private cloud environment, and shut down the data center. But you're not really getting the most value from the cloud from that. It's a good way to start your modernization journey in order to progress and both improve the application and save a bit of money. Second option is move and improve. So for example, and this is specifically relevant for the Anthos and Kubernetes environment, is we have seen customers who have monolithic applications running on-prem, but they don't want to, they're very regulated, it's high risk, so they want to kind of build it out on-prem while moving it. So you'll set up a Kubernetes cluster on-prem, and you'll start strangling the monolith, decomposing the monolith into the Kubernetes, and you'll have 2 environments running until the monolith is decomposed or until you get to the certain level that you want to get of decomposition. You can run that in Kubernetes on-prem, and then you can take that and move it up to the cloud. Another scenario would be to set up the cluster in the cloud and do the composition from on-prem to the cloud. Another use case, like I said, is regulatory requirements where you have certain parts of the application for data regionality aspects. I know Australia has pretty strict data regionality requirements where data isn't allowed to leave the region, leave the country's border. So that would be another use case where you would have both a private cloud and a hyperscaler cloud scenario. Another scenario which is pretty relevant both for retail or gaming or any kind of application where you have bursty workloads. So for example, if you're in AWS or Google and on-prem, and your main application is running on-prem, and all of a sudden you have a Black Friday or a Cyber Monday or when COVID started, the amount of users for gaming applications 10x. They were able to scale their workloads into the cloud and just use the on-demand capacity from the cloud. Another scenario is HA and DR. This is a scenario which is very, very complicated, right? There you have to have very good definitions of what your availability and disaster requirements are. So from a DR perspective, you can have either cold, warm, or hot DR scenarios. Cold and warm is more relevant, where, for example, if your on-prem environment or environment in AWS goes down, then you can spit up a replica environment of that in Google Cloud and continue serving your customers within your RTO. HA, high availability environments across clouds and across on-prem environments is very difficult to set up, because you have to think about not only having the application up and running and a load balancer between the two, between AWS and Google Cloud, for example, but you also have to think about data replication. So for example, if you take a very simple just Kubernetes connected to RDS on Amazon, and you want to set up an HA environment on Google Cloud, you have to think about, okay, how do we replicate the data from AWS to GCP? How do we manage who's the master, who's the leader, who's the worker nodes? How does the failover mechanism work? It's very, very complicated to set up HA. And it's one of the least used scenarios that I've seen. It's one that's very interesting to everyone, but very few people can actually implement it well. For a multi-cloud scenario, like I said, one of the use cases is using the best cloud for your use case, right? So if you have a very heavy data analytics part, you might want to use Google, or a very heavy Kubernetes thing. Google is also great for that. But if you have certain services which AWS provides, then you might want to use that for those services. And the final part, and this is not, if I was going to make a decision around setting up a multi-cloud environment, avoiding vendor lock-in would be the bottom of the totem pole. If you build applications smart enough now, you can do it. But also, if you're building things to avoid vendor lock-in, then you're necessarily not taking advantage of all the great tools that lots of the vendors have, and you're doing a significant trade-off there on your operational overhead in order to avoid vendor lock-in. So there are trade-offs to that, and it's not necessarily the main reason I would do it. Now, when looking at a multi-cloud environment, what are the tech stack and required capabilities to take into consideration? So first of all, we need to take into consideration, and this is, I put it at the top because it's the most important thing, and a lot of tech people skip over it, which is the organizational impact of this, right? So when you modernize an application, for example, you're not only saying, okay, now instead of moving it from VMs to Kubernetes, you also have to modernize how your development teams work, how your DevOps teams work, how people deploy and update code. You have to train the teams on the new technologies. And there is a cost perspective. So when you're running multi-cloud and hybrid cloud environments, until one of the environments shut down, it's very expensive. It can get extremely expensive. You can be running replica environments until one of the environments is shut down. And even if you're not planning to do that, you have significant egress costs between the different clouds. So taking into consideration this, and taking into consideration that it takes time to make a change. So that's one thing. On the compute side, we need to understand that running VMs on VMware on-prem is different than running GCE, Google Compute Engine instances, or EC2 instances, and how you define them and how you operate them and what the capabilities are different. Same thing from Kubernetes. running databases and storage. So if you have to operate SQL servers or MySQL on-prem, and then you're moving to the cloud, and all of a sudden you're using tools like Bigtable and Cloud SQL and Spanner, which is a highly scalable, multi-region SQL database. Things are different, and it takes time to learn it. From a networking perspective, there are massive differences between how things are done on-prem, on AWS, and Google Cloud. So for example, in Google, you've got a global VPC, where you can just set up a single network that's global for your environment, and you define subnets in each region. Something like that isn't possible in AWS. You have to set up a VPC per region and then configure the networking between the two. It's very, very difficult to define that. And one of the mistakes that I see a lot of people doing is trying to take what they're doing on-prem and do the same in the cloud. You're losing a lot of benefits by doing that. It's better to have a thoughtful conversation of what the networking environment is going to look like and how to use the benefits to that. Setting up security environments, same thing, right? There are different security tools depending on the applications and cloud vendors you use, and each one of those requires learning and requires implementation. There are certain stacks like Splunk and Datadog, which give insight into your monitoring and some security and other types of things, which do work across environments, but you still have to set that up per environment. Running CI/CD and DevOps, right? For a lot of companies, it's a new challenge. How to do this properly, how to securely build images, containers, deploy them across environments, monitor those environments, learning tools like GitLab or Spinnaker for your CD tooling. There are quite amount of significant differences between the environments. And finally, authentication, right? What's your single source of truth? How do you federate that between the different environments? How do you manage single sign-on? There are a lot of things to take into consideration when setting up a hybrid and multi-cloud stack. So what's the recommendation, right? I've been giving a whole lot of, whoa, think about this first before you do it. There's a lot of complicated things here. So the easiest way to do it, and it is the way the world is going. Companies are moving to multi and hybrid cloud scenarios for a reason. Best thing I can recommend is to start slow with a small workload, set up one Kubernetes cluster, deploy a single pod, set that up across environments, learn what you're doing on the smallest, most negligible part of your infrastructure, and then start to move faster. Once you know that, and once you have the tools and things built in place, it'll be exponential how fast you'll be able to run and deploy things. I love the saying from Martin Fowler, the only thing a big bang rewrite guarantees is a big bang. And that's very important to take into consideration when trying to do these changes. So how do we do this, right? At DoiT and Google, and how do we help support our customers, right? 4 stages. Start with assessment. Have a look at what you're currently doing. Understand and prioritize what's high impact, low difficulty, high impact, high difficulty. There's a whole matrix about this. And based off that, plan out what you want to move and what you want to refactor, when and how. Secondly, deploy it. Make sure it's running as it is. Don't try and optimize things. A lot of companies, when they jump into these projects, try and do cost optimization, try and do application optimization, try and add, we need to insert this feature in while they're doing the migration. And that's just a mistake. I've seen it kill multiple projects where that happens. So the best thing to do is take what you currently have. If you have to refactor it, change it a bit, don't add functionality, don't optimize it. Just refactor it, move it, and then optimize. It's much more efficient and allows you to learn a lot better. So how do we build the stack? So Anthos, right? And this I purposefully wrote here in the title is the application layer, because it handles the application layer. Yes, you can have databases which run on Kubernetes, but it's not all the databases. And I would be cautious of tying what I have to do in order to make sure that databases can run in Kubernetes. It's a very advanced topic and not every company is able to do it. So Anthos is part of the solution. It is not all of the solution. Anthos can significantly help with the application layer, with your code and refactoring it and running it on Kubernetes across multiple environments. But it's only part of the solution, and it's not just let's rub some Anthos on this and it'll make everything better and more reliable and so on. It helps, but there are a lot of other things to take into consideration. So what does Anthos look like? This is a high-level architecture, right? You have Anthos running on Google, on-premise, other clouds, and attached clusters. An attached cluster could be any cluster that can just be attached into the environment for monitoring perspective. So for example, if you have an EKS cluster that you don't want to move to Anthos, you can just attach it and have the visibility and the control through Anthos. You have everything is built out into fleets. This is a new terminology. You have a fleet of all your clusters where you can manage your configurations and your service meshes. You have the Anthos clusters, which are essentially your Kubernetes clusters running across environments. You have ingress for Anthos, which helps with multi-cluster ingress. So for example, in the media and streaming environment, you could essentially set up a cluster in EMEA, a cluster in North America. You have a single global load balancer, and you have a multi-cluster ingress that routes the traffic to the clusters according to what's going to give the customer the best service, the best functionality and performance. Then you have Anthos Service Mesh, which is essentially a managed version of Istio, allows you to pull telemetry and set up additional security controls between the pods and your services, and also to help with security. And then you have Anthos configuration management. So one of the big issues that we've seen with customers is you set up a cluster on-prem with a certain configuration. You have cluster in Google Cloud with a certain configuration. Everything's managed separately, and ultimately there's configuration drift. So with Anthos configuration management, you can essentially manage your configuration across all your clusters from a single place, and it just makes things a lot easier. On top of that, you have obviously APIs and CLI that you can interact with everything, and you can also deploy certain applications and other tooling to the Anthos clusters. So marketplace solutions, Cloud Run, certain machine learning things. There are various different things that are happening around this. So a bit of a demo. I'm being cautious of my time. So in this demo, what I've done is I've set up 3 clusters, one in AWS, one on Google Cloud that's a standard cluster, and one that is an autopilot cluster. Difference between standard and autopilot is autopilot takes care of all the cluster configurations for you, all 95% of the cluster configurations for you. All you have to do is define your deployment, send it to that cluster, and then it will be responsible for spinning up the nodes in the regions, in the zones, and Google takes care of everything for you. So this is a pretty complex architecture diagram. This is from Google's good old microservices demo called the Hipster Store. Essentially builds out about 9 different deployments on a Kubernetes cluster with a front end, with a load generator, with a cart service, and all types of other things that it ties into. This I've deployed to our autopilot cluster, and I'll show you a demo of what that can look like. I have set up an Anthos on AWS cluster. This at the end, there's a reference to GitHub to how to set this up. There's pretty great Terraform that Google's built out that in under 30 minutes, you can set up your own environment running Anthos on AWS. Really, really simple and useful. The launch time takes about 12 minutes from the time you hit Terraform apply, so I won't do it in the demo. Essentially, what it is setting up is a VPC with 3 control plane nodes, each one in a different zone, and a node pool that can auto scale from 2 to 5 nodes. That connects to the Google Connect API, and we control everything through the Anthos environment. This is essentially what the VPC network looks like. You have a single VPC, as I said, control plane node in each one. We have an internal network load balancer for them to communicate with the nodes in the different zones. You also have a private subnet for these, obviously, and a public subnet for things to be able to access the outside internet. Let me share my screen. So let's go to Anthos. So can you see my screen? Yes. Okay. So essentially, this is the dashboard you see when you join Anthos. You can see a very quick view of your cost, how much it's costing on AWS and how much it's costing on Google Cloud. You can see if you've got service mesh and configuration management set up. I don't have it set up for this scenario. That would be a very long demo. And you can see your clusters. So essentially here from a single place, you can see I have my autopilot cluster, I have my AWS cluster, and I have my standard GKE cluster. From this, I can also create a cluster. So for example, if I want to launch a autopilot cluster, like I said, which is very, very quick, it takes a bit of a longer startup than a standard cluster, but as you can see, it takes care of nodes, it takes care of the networking, it takes care of security and telemetry. We just have to define where it is, what region we want it in, if we want it to be a public or private cluster. You have a bit of control around networking. I'm not going to play with this. And then you have some advanced options that you can touch on. But essentially, it's very, very easy to set this up. So I'll just create an autopilot cluster so you can see it spinning up. And in the meantime, I will show you a bit of the workloads that we have. So if we go to our, if we go to our environment, if I go to my current autopilot cluster, I can see the information about that. I can see where the zones are. I can see if I have vertical pod auto scaling enabled or not, notifications, networking, all the different things about that cluster. If I go to my monitoring dashboard, one moment, we'll be able to see the various different information that it'll share. So as you can see here, from a single pane of glass, I've got all my clusters, very simple monitoring that I've set up here. I can see how many nodes have set up. So the autopilot cluster, because I deployed that very complicated hipster shop demo, it spun up 16 nodes to contain all the different pods. I can see the AWS cluster currently has 4 pods because 4 nodes because I spun up Nginx deployment on it. And on my cluster 1, I also have deployment. I can also see the various different monitoring things from here to monitor our node. Now, how to do a deployment, right? How can we use this and deploy things across environments? If I go to my clusters, right, I can do deploy. For this scenario, I'm just going to deploy a simple Nginx. And obviously, this can also be done through the CLI. If you just if you do a kubectl set context to the name, you can set up the context of which you're going to deploy it to, and it'll work the same. So do an Nginx deployment, and then I can choose where I want to send it to. So I can send it to my AWS cluster, or I can send it to my GKE cluster. In this scenario, I'll send it to GKE. I hit deploy, and then you'll see I'll have another deployment running on my GKE cluster. Currently on my AWS cluster, as you saw, we have 2 Nginx environments running. Let me just see the workloads. Go back here. We can see the list of workloads. So you see I have 1 Nginx deployment running on AWS, 2 Nginx deployment on AWS, and another 2 running on cluster 1 on GKE. Everything from the same place. Everything is controlled through the same thing. And the Kubernetes clusters are essentially all controlled through the configuration done on Google Cloud. That's it for the demo. We'll do a summary. So essentially, things I wanted you to take away from here. 1, building a hybrid and multi-cloud solution is both difficult and expensive. There are ways to do it, but it's something that has to be taken into consideration before starting the journey. There are many great multi-cloud solutions like Anthos, but no one technology will provide you with an end-to-end solution. Nothing is going to tell you, just rub this on and it'll fix everything for you. You can use tools like Anthos to make things a lot easier. It's easier for companies that are currently running K8s in production at scale to set this up. Companies that are either legacy, more monolithic focused, there is about a 2 to 3 year learning curve in order to set this up. And small startups simply don't usually have enough people to successfully operate a multi-cloud environment. So the sweet spot for making this decision is companies who are already running Kubernetes in production. But as I said, you can make the decision. Just be aware of the scale-up speed, the scale-up time, the time for your teams to come up to speed and know how to operate it.